How would you describe your method?
My method?
Yeah, your method, the pedagogy. How do you describe your
Well,
pedagogy?
I've had this luxury, this wonderful opportunity to see the blocks, and these blocks structurally represent math. I started using them when I worked with kids with learning difficulties because a lot of the kids couldn't picture the numbers. They just seemed like one of my students said to me, the problem with math is that you start counting and you don't know when to stop. So when she saw the blocks, it was a huge difference for her because she began to pick up a 10 and pick up a 9 and figure out how big they were, and 5 in relation to 10 and how big that was. And so she began to step outside of just the counting and be able to see the bigger picture of what math, to see the relationships, the patterns. So over the years, I've had this wonderful opportunity to play with these and try the structural arithmetic activities over and over again and see how they work with different kids. Then this year and last year, this is the first years I've worked with kids who love math and like to think mathematically, right. And I've been using the materials with them as well, and they really benefit from them highly as well. So I've seen a big range, and then I go into the classrooms and demonstrate, and they use the materials.
And we'll see some of that large
yes.
group sort of thing later.
Mm-hmm.
Do you treat the kids, the advanced kids, any differently do you work any differently with these two groups of children?
Well, every child that you have, you try to figure out where where they're coming from, their strengths or their weaknesses, and use their strengths to actually address their weak areas. But also you try to challenge them as much as possible. So I found actually working with the enrichment kids is very similar to working with kids who have some learning difficulties, because I'm always trying to figure out what's the next step, how to challenge them in the next step. So it's similar in that way. It is a lot faster though. I find that the acceleration, they go a lot faster. So that the enrichment kids are the kind of kids that I have that ask the next question. So I have to be ready for that next question
right.
and to run with that. So they're always questioning, always asking for more. So the speed that they learn the math is a lot faster.
I noticed that they express their thinking very well. They were constantly talking and saying, I did this because, and guess why, and all this sort of thing. Were the kids having learning problems any different in that area?
Well, one thing I do in my classroom is, from the very beginning, I've asked kids to express their thinking.
Right.
So some of the second grade children I've had actually for 2 years. So from the very beginning, they need to prove and
right.
explain what they're thinking. So that's actually, if you ask what my pedagogy is, I spend a lot of time
right.
saying, you're a mathematician, and I want you to explain
right.
how you thought through something. With kids who have learning difficulties, some of them have language difficulties, and the curriculum, structural arithmetic, allows the kids actually to be teachers at times. So all the games that I was doing today, the students can have a turn being a teacher. Like we were getting up here too,
right.
and so with kids who have language difficulties or expressive difficulties, it's wonderful because they have to, at the same time as they're doing things, express what they're doing.
Right.
So it does, words have the words are tangible with the math. That's what I love about math, is that when they say words, they can pick up a block and they can see that 8 and 9, it's not just a word in their mind, but
right.
it's
They're always
tangible.
Relating it
yes,
to these.
So it does help kids who have expressive difficulties because it's very tangible and they can pick up things and talk about the relationships.
And do they end up talking about their own thinking as well, those kids with learning problems?
It depends on the child.
Okay.
Some kids are much more verbal than others. Some kids actually tend to talk through everything, and that's how they learn.
Mm-hmm.
So depends on the child.
Okay. So as we were doing this, I saw all the interesting things you're doing, and then I imagine teachers' reaction to this, and they say, "Oh, well, these are exceptional kids.
Mm-hmm.
We could never do this in our classroom." How would you respond to that?
Well, that's why this afternoon we're going to do a whole class, and Toby, actually, who's tucked her head in here, is the teacher there. She has loved the materials, and she's been doing it with her whole group. And I actually, for 24 years before I worked with the kids who are accelerated, worked with kids who have learning difficulties and found the benefit of them. I think sometimes people thought that because kids who have learning difficulties in math, the structural arithmetic, they benefit so much from it, that people thought that this is really for kids with learning difficulties. So now I'm finding that, I mean, the kids who love math love these materials because they represent what they've been thinking, and they can see the patterns and the relationships very quickly when they see the block. So both ends really benefit, and then all the ones in the middle, we have here we have a lot of different small groups, so that kids, all kinds of kids, can benefit from the materials.
Why is this called structural math?
Because it's structural.
Can you explain that?
Because you can see the structure. Okay, so for instance, I think often kids in the younger grades learn math by counting individual discrete pieces. So that if you have, they end up counting all these little things. So if you're learning to count in kindergarten or first grade, you're doing a lot of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you're getting lost in all the little pieces. And also, you're not sure by the time we finish this whether this is 6 or 8 or 5. You're not sure about it. But with structural arithmetic, you can see the structure. You can pick up a 5. Very young age, and you know this is a 5, and you know this is a 10, and this child said this is a big 9. And if I see these, this is 9 here. And this is 8, I guess, but you can't really see 8-ness or 9-ness there, so you can see the structure here. So then, once I see the structure, and I know that this is a 9 and this is a 1, I can easily see that this is the same length as 10. So I think she thought of it because you can see the structure. You can step outside of all the discrete pieces and see the bigger picture.